Dear students, welcome to a new video for Descriptive Statistics course. We already began in the previous video the measures of central tendency, and we take the arithmetic mean, geometric mean, median, mode. Now we will begin to study the geometric mean. The geometric mean is one of the useful measures of location, or what's called by measures of central tendency, because it's useful in finding the averages over time. Now, if we have a case or situation for finding the average over time, the most suitable is the geometric mean. So, the finding averages, changes, ratios, or growth rates over time, we will use the geometric mean by using this formula, which is GM equal to the nth root for multiplying x1 times x2 up to xn. This means the values for our study equal or variables, which is x1, x2 up to xn, which is n the size of our sample, will be multiplied by each other, and we will take the nth root, which is the number of the sample size. Here there is a wide application in business that are often interested in finding the percentages in sales, salaries, and GDP. So the geometric mean is very widely used in business and the applications in it. And for mathematical calculations, the geometric mean will be always less than or equal the arithmetic mean. This means if we have a same situation and the same sample and getting the geometric mean value by multiplying the variables and take the nth root and take for the same sample the arithmetic mean by adding the values and divide by n, the value for the geometric mean will be always less than or equal the arithmetic mean, never be greater than. Let's take an example for the geometric mean situation. The return on investment earned by construction company for 4 successive years was 30%, 20%, minus 40%, and 200%. What is the geometric mean rate of the return on investment? Please concentrate for the values that we have in our problem. We have 30% in a positive value, 20% with a positive value, and minus 40%, which have negative value. What's mean by the positive values and negative values? The positive values mentioned or mean the increasing in this year. So there will be an increase for the investment in this year. But the negative values is mentioned for the decreasing in the investment in this year. So this is the difference in between the positive value and negative value. Let's start to get the geometric mean. To get the geometric mean, we haven't an information for the values, but we have information for the percent that the values is increased or decreased by. So to get the value for the first year, we will have 1 plus 30% increasing, this means 0.3, to get the value for the first year equal to 1.3, as mentioned here. And for the second year, we have 20% increasing because it's a positive value. So we have 1, which is a base value, plus 0.2 increasing value equal to 1.2. So this is the value for x2, which is equal to 1.2. Take care again. Here we haven't the actual values, we have only the increasing values or decreasing values. So we should calculate the actual value from it. Now let's move to the third year. The third year we have minus 40%. Minus 40% means that we have a decrease in the investment in this year. So we have 1 minus 0.4, which is equal to 0.6, to get the value for the third year equal to 0.6. Finally, the fourth year, the value for increasing, which is have a positive value equal to 200%, which is equal to 2. So the value here will be 1 plus 2 equal to 3. This is for the fourth year. Multiplying the four values, which is for CSU 1.3 times 1.2 times 0.6 times 3, and we get the nth root because we have 4 successive years, so we will get the fourth root for multiplying the 4 values. So after multiplying the 4 value and get the fourth root, we will take the values for the geometric mean, which is 1.294. So this is a case for a geometric mean for the 4 successive years. Now, let's move to another application for the geometric mean, which is finding an average percent change over time. This means that we have 2 periods, ending period and starting period, and we wanted to know what is the average change over time. What is the change that occur for this case from the beginning to the ending? In this case, the most suitable measure of central tendency and measure of location is the geometric mean. But the formula for geometric mean to get the average percent increase over time is a little bit different because it has this formula, which is equal to GM equal to the nth root for the result of dividing the value at the end of the period over the value at the start of the period. And this value, we will subtract 1 from it. Now, again, if you have a situation that want to have an average percentage change over time, and you have a starting period and information in the starting period and ending period, and you have information in the ending period, you should use the geometric mean by using this formula. Let's start an example to be more clearly for this formula. During the decade of 1990 and into the 2000s, Las Vegas was the fastest growing city in the United States. The population increased from 258,295 in 1990. So it is the starting period for us. And the increase from this value to 607,876 in 2009. This is an increase of 349,581 people, or a 135.3% increase over periods. The population has more doubled. So what is the average annual increase? Simply, this situation is repeated every calculations for a government state to decide what is the rate of increasing for the population in a given area or a given country to have decisions about education statements or hospitals, how many hospitals, or what's the value, or what is the services that can afford for their citizens. These all decisions depend on the rate of increasing of the population in this city or this area. So they should know the annual increase or annual rate for this population. Now we have a value in the beginning of 1990 and the value of ending and the ending value, which is for 2009. And we will applying in the geometric mean for the annual increase by using this rule. the value at the end of the period, which is equal to 607,876 over the value which in 2009, of course, was in 2009, and over the value of the starting period, which is equal to 258,295, and this value was 1990 in the start period, and taking the 19th root for this, which is equal to 9 here, 2009 minus 909 equal to 90. So we will take the 19th rule. We will take the 19th root. And after taking the 19th root for this value, we will subtract 1 from this value, like in the formula, to get the geometric mean for annual increase, which is 0.0461. And this is the other application for the geometric mean. Now we already finished the geometric mean and covered the central tendency measures in the 5 values for arithmetic mean, geometric mean, weighted mean, median, and mode for ungrouped data. Let's move to another important point, that how to get the mean and median for the group data. As stated in chapter 2, that we can convert the ungrouped data to a group data for any situation by getting the classes and tally the classes and getting the frequency in each class. Then we can calculate the cumulative frequency and the midpoint class and other measures that we get from the group data. Now, if we want to have a mean or get the value of the mean for the group data, what can we do? We can find the mean for the group data by applying the following steps. First, we will take the distribution table, frequency distribution table, by getting the classes, like the classes that we have in chapter 2, and then get the frequency in each class. Then we want to get the midpoint, which is very important, that we want to this value in our rule for the mean for the group data, and then multiplying the frequency column by the midpoint column. This means the value of the second column will be multiplied by the value in the third column, and we will want to get the value here. Then we will sum all the values in the fourth column and use it in the following formula, which is the mean for the group data x bar will equal to summation f, which is frequency in each class, times the midpoint in the same class over the total sample size equal to mean. Okay, let's take an example. Using the following frequency distribution, find the mean. The data represented number of meals run during the 1 week for the sample of 20 runners. So we have n equal to 20. This is a very good information for us that we have n equal to 20. Now let's start making the steps for getting the mean, like the previous table. First, we will get the frequencies that's already given. Now we will get the midpoint in the first class. The midpoint equal to summation for the upper limit, which is 5.5, plus lower limit, which is 10.5, and divided by 2. So the value here will take the midpoint in this column. So we will take the midpoint for all the classes in the third column. Then multiplying the values resulted by the midpoint and get the values like this. So here, midpoint for the first class equal to 8, the midpoint for the second class equal to 13, the midpoint for the third class equal to 18, for the fourth class 23, and this is all getted by adding the upper limit to the lower limit and divided by 2. Here we will finish the midpoint column to move to the other column, which is finding f frequency multiplied by the midpoint for each class. So we will multiply this column P by C to get the column equal to D. So 1 times 8 equal to 8, 2 times 13 equal to 26, 3 times 18 equal to 54, 5 times 23 equal to 115, and so on. Then finally, we will add up all the values in the fourth column, which is the equal to 420. This value represents the summation for the frequencies multiplied the midpoints, and this will be the numerator for our rule. We'll divide it by n to get the x bar value, which is 420 over 20, 490 over 20 equal to 24.5 mils. So this is the average arithmetic mean for the group data. The steps is very easy. We already take the how to get the values for the midpoint and the frequencies classes. You just substitute in this rule. So be careful that the rule differ. The rule for group data is different from ungrouped data. In the case of ungrouped data, we already take the all values, adding them up and divided by the total sample size. It's a direct. But here you should take into consideration that the value is group data, so we should get the frequency in each class and multiplying the midpoint and adding them up and divided by the n like this. Now let's move to how to get the median for the group data also. Now to get the median for the group data, we will construct the cumulative frequency distribution table like this value, like other cases in the previous chapter, that we have a column for the frequency, cumulative frequency. Step 2, decide the class that contains the median class, the first class with the value of cumulative, that's equal to n over 2. Find the median by using this formula. Lm plus n over 2 minus f over fm equal to I. Let's take each simple meaning. N, of course, you know that is the total sample size or the total frequency. F here mentioned for the cumulative frequency for the classes before the median. Before the median. Take care of this. That F only, not Fm, F only the cumulative frequency before class median. Fm the frequency for the class median. I the class width or interval, and we already know this information. I the class interval or class width. Lm is the lower boundary for the class median. Now let's distinguish between Fm and Lm. Fm and Lm with a subscript m. This means we are standing on the class median. So Fm the frequency of the class median, and Lm is the lower boundary for the class median. But the F capital F the frequency before the class median. Okay, let's take an example for more. Based on the group data below, find the median. Of course, we have here a group data and it's the associated frequency and want to get the median. Let's applying the rule for the median for the group data. In the first step, we will find the cumulative frequency. Of course, you already take the cumulative frequency column and finding the values where we 8 added for nothing, which is 8, so the first cumulative value with 8, then 14 added for 8, equal to 22, 12 added 4, 22 equal to 34, 9 added to 34 equal to 43, and finally in the final class, 7 added to 43 equal to 20. And the value here, which is 50, equal to the total number of values given, or the total frequency number. Also, it is our n. N here equal to 50. This is the value. Okay, we have the first one. Now we want to decide f. F is our median for our frequency, cumulative frequency for the class that before the median. Now, how we can decide the median? We decide the median that we have 5 classes. We have 5 classes. So the median class, that's a class that in the middle, which is from 21 up to 30. Now, this is here we decided that the median class for this region will equal to from 21 to 30, and its frequency equal to 12, and its cumulative frequency equal to 34. Recall again the median rule that we in the median rule, that's for the ungroup data, we arranged the values, then take the value that in the middle. So in this situation, maybe it's a little like the ungroup data, because we arrange by using the cumulative frequency and take also, in the case of all number of classes, the value of in the middle to be our median class. So we decide that this will be our median class. And from this decision, we have a value for f, which is the cumulative frequency that before the median class. We decide this is the median class, so the value f equal to 22. And fm is the cumulative frequency for the is the frequency for the median class. Median class, the value for frequency for the median class that we decided. And Lm is the lower limit for the median class that we decide, which is equal to 21. Here we have all the symbols in the formula for the median for the group data. We just putting these values. That is, we have n equal to 50, which is the total number of frequencies or total number of sample size, and f equal to 22, which is the value that is before the median class, and fm equal to the frequency of the median class, and Lm equal to the lower limit for the value for the median class, and I is the width of the interval. Substituting in the rule, we find that in 25 minus 22 over 12 multiplied by 10, and the value will add it up to 21 equal to 23.5, which is the median in this case. This means that 25 persons take less than 24 minutes to travel to work, and another 25 persons take more than 24 to travel to work. This is all for the median and the mean for the group data. Now let's take an overview for the properties for the central tendency. We have the 3 main measures, which is mean, median, and mode. We have a special cases of median, which is of mean tariff, which is arithmetic. The mean included the geometric mean and the weighted mean, and then we take a median and mode. What is the differences in these measures of central tendency, and what is the properties for each one? For the mean, is we found it by all the values of the data. All the values are used to get the mean. Whatever we get, the arithmetic mean, the weighted mean, the geometric mean, we use in the 3 cases all the values, and we don't omit any value or exclude any value from the calculations. Number 2, The mean varies less than the median or mode when the samples are taken from the same population and all the three measures computed for less these samples. So it have less vary. The variation is less than the mean. Number three, the mean is used in computing other statistics like the variance. If the cornerstone for calculating the variance is the mean. When we take the measures of variation or dispersion in the next video, we will have to calculate the variance, and the variance depends on finding the mean in the first step. Number four, the mean for the data set is unique and not necessarily be one of the data values. This means if we have two values, 2, 3, and 5, for example, we adding them up and divided by 3 to equal to 10 over 3, which is maybe 3.333. The result of this mean in this case is not one of the values that we have. And and we have only one value, so the mean is unique. The mean can be computed in the case of the group data for the open-ended classes. For the mean is affected by extremely high or low values, that is called outlier. What's meant by the outliers? The outliers that the values that may be is very far from the actual value. It may be caused because of the person who gathered the information is pod number different, get the information that it's not accurate, but the results that we have an outlier in our sample, so the mean is affected by it. Why mean affected by it? If we have gathered the value for that 2, 3, 5, and get the value 100, and this is the values that you get, and you add them all up and divide it by 4. Whatever you are have a doubt and this value, what 100 maybe 10, not 100, you can't get it 10 from yourself. You should add the values as it. So the value of the mean will be extremely different if the actual value was 10, I mean the 2, 3, 5, and 10, and when it's 100. The value of the mean affected here by this outlier, maybe its actual value was 10, not 100, but you should included this value included in the calculation, and they added them up to the other value and divided by 4, so the value of the mean will be affected very much. The median, let's take back the probability of the median. The probability of the median is used for center or middle of the data set. We only interested in the middle. Arrange the values ascending or descending and take the value in the middle in the case of the odd numbers, and taking the values, two values in the middle in the case of the even numbers, and divided by 2. So we are interested in the middle or the center. Number 2, the median is used when the necessary to find out whether the data set fall into the upper half or lower half, because we want to know the location of the data. Number 3, the median is used to open-ended distribution. In the case of the group data, it differs from the mean. Here the mean can be used for the open-ended classes, but the median used for open-ended distribution. Number 4, the median is affected less than the extremely high and low values because we arrange the values. When we arrange 2, 3, 5, and 100, so the 100 value is out of our calculations because then it's outlier, and the value here after arranging is in the last point. So we take the two values and divide it by 2 and get the median. If the value was 10 here, the result will be the same. So in the case of the median, it's not affected by extremely high or low values. Then we will move to the probability for the mode. The mode is used when the typical cases desired, and we want to get how frequent is this case is repeated. So the most suitable measure of central tendency here is the mode. The mode is easiest average compute. We just allocate the number of repeated values and get the largest frequency or greatest frequency and find out the mode from it. The mode can be used when the data are nominal, critical, and such as religious preferences, gender, or political affiliation. So we have a very important uh, here points for the mode, which is not included or not. We can find it in the median and mean when we want to get the data mode for or we get central tendency for the data that are nominal or categorical. We find it by using the mode. We can find it by the median or the mean. Finally, the mode is not always unique. It may have more than one mode. The data set have more than one mode or three modes, two modes. If the same the number frequent or the number of frequency repeated many times. So we have more than one mode. That's it for all the measures of central tendency or what's called by the measures of location. Now you have exercises for the this part of the chapter. Two more practice. It's very easy. Please try to solve these exercises because it's a direct information and the calculations is very easy, and substituting it directly in the rule. Just study first and then practice by using these uh, exercises here. This is all for this video, and in the next video we will begin with the measures of variation or what's called the measures of dispersion. Thank you.